Welcome back. Section 1.7. In this section, we introduce you to combinations of functions or composite functions. Before we actually consider the composition of two functions, we're going to look at the algebra of functions. If I have two functions, can I add them? Can I subtract one function from another function? Can I multiply the two functions? Can I divide a function by another function? So, combining functions. So let's assume that we have two functions, f of x, which is defined as x minus 5, and g of x is defined as x squared minus 1. So we're going to find each of these operations here, this sum. So as I said before, as we consider the algebra of functions, if I have two functions, yes, indeed, we can add them. So f plus g of x is going to be f of x plus g of x. So f of x plus g of x. So f of x is defined as x minus 5. So f of x is x minus 5. And I want to add to f of x g of x. G of x is x squared minus 1. Combining my terms, I have x squared plus x minus 5 minus 1 is a negative 6. So f of x plus g of x is x squared plus x minus 6. In the next example, let's consider if we multiply f by g. So f times g of x is going to be f of x times g of x. So f of x times g of x is going to be f of x. F of x is defined to be x minus 5. G of x is defined to be x squared minus 1. X squared minus 1. So f of x times g of x is the product of these two factors. So let's see, if you want to simplify, you can do the multiplication, and let's do that. So we got x times x squared is x cubed minus 5x squared minus x. And then finally, a negative 5 times a negative 1 is a positive 5. And there we are. There are no like terms. So when we multiply f of x times g of x, this is our product. X cubed minus 5x squared minus x plus 5. In the next example, we want to consider the quotient of the two functions. That's f divided by g. So this really means f of x divided by g of x. Although there's one condition. The condition is that g of x not be 0. Cannot be 0. So let's see what happens when we attempt this division. So we have f of x. F of x is defined to be x minus 5 divided by g of x. G of x is x squared minus 1. So this is the quotient. This is f of x over g of x. In this example, we introduce you to now composite functions. All right, we denote the composition of two functions. So we're given two functions, f and g. and we want to consider the composition of those two functions. That is, one function composed with the other. So here we have f composed with g. That's not a times, that's composed. F composed with g. So f composed with g is f of g of x. F of g of x. That's not f times, this is read f of g of x. Now, let's really see what it means to compose one function with another. Let's really see what this, let's illustrate by using an example let me call it the function machine. So we start with the innermost function here, g of x. So if we have a function g of x, so g of x is my function, that's my function, y is equal to g of x. All right? Now, let's see what happens. How would we, so this is the domain of g, so I got x. Let's say the x, of course, is in the domain of g. If I apply g to the element in the domain, I get what? I'm going to get g of x. G of x is actually in the what? In the range of g. So after applying the function g to x, we get g of x. And g of x is in the range of g. So I have, that's g of x. Now I want to take f of g of x. Now I'm going to apply the function f to g of x. So what happens then? So what's happening? If I begin here with g of x, then g of x, the set of all values of g, will also represent the domain of f. So this is my domain. So if I take an element in the domain, g of x, and apply f to g of x, this is going to be f of g of x. And then this set then becomes the range, the set of all values in the range of the in the range of the composition of the two functions. So that's an example of how to illustrate the composition of two functions. But let's now consider a concrete example. So let's consider a concrete example of composite functions. So if we're given two functions, f of x, which is defined as 5x plus 6, and g of x, which is defined as 2x squared minus x minus 1. So let's find the composition of f and g. So this is f composed with g. In other words, this is f of g of x. All right? So let's see what this is. So we begin with g of x. Remember, g of x is now the domain of f. G of x, in this case, is g of x is defined to be 2x squared minus x minus 1. So this is f of g of x. Now I need to evaluate the function f at g of x. G of x is 2x squared minus x minus 1. F is defined to be 5x plus 6. So f of 2x squared minus x minus 1 is 5 times 2x squared minus x minus 1 plus 6. And if we simplify this, I got 10x squared minus 5x minus 5 plus 6. Combining like terms, 10x squared minus 5x plus 1. So this represents the composition of f and g, f of g of x. So this is actually f of g of x. In the next example, we're now composing g with f. So g composed with f is really g of f of x. So g of f of x. F of x now is 5x plus 6. So for f of x, we just substitute 5x plus 6. So now we want to evaluate the function g at 5x plus 6. G is defined to be 2x squared minus x minus 1. So therefore, g of 5x plus 6 is going to be 2 times 5x plus 6 minus 5x plus 6 minus 1 squared. Did you catch that? I hope you did. All right, because 2 times x squared. So this is 2 times 5x plus 6 squared. So let's simplify this. All right, so this is 2 times 5x plus 6 squared. 5x plus 6 squared is going to be 5x squared is 25x squared. 6 times 5x is 30x times 2 is a positive 60x plus 6 squared, which is 36. Minus 5x minus 6 minus 1. Simplifying, we have 50x squared. 2 times 60x is 120x plus 2 times 36 is 72 minus 5x minus 7 minus 6 minus 1 negative 7. Combining like terms again, we have 50x squared, 120x minus 5x is a positive 115x, and a positive 72 minus 7 is a positive 65. So therefore, g of f of x is 50x squared plus 115x plus 65. In the last example, we want to compute f composed with g, but this time at a negative 1. So this is really f of g of a minus 1. So that's really what you're computing there. Right? So what do we have? We have f of g of a negative 1 is going to be f, all right, g of a negative 1. Well, here's g. So I need to now evaluate g at a negative 1. So at a negative 1, g is going to be 2 times a negative 1 squared minus a negative 1 minus 1. All right, let's simplify this. So we got f of 2 times a negative 1 is 1, minus times a positive 1 minus 1. So we have f of 2 plus 1 minus 1, 0. So this is f of 2. Now continuing. Now we want to evaluate f at 2. F is defined to be 5x plus 6. So f of 2 is going to be 5 times 2 plus 6. 5 times 2 is 10, plus 6 is 16. So therefore, f of g of minus 1 is 16. So let's consider another example. Given the function f of x is equal to 4 divided by x plus 2, and g of x is defined to be 1 over x. So f composed with g is going to be f of g of x. So let's see what this is. So we want to evaluate f at g of x. But g of x is 1 divided by x. So now we want to evaluate the function f at g of x, which is 1 over x. So f of 1 over x is going to be 4 divided by 1 over x plus 2. And let's simplify this. So we simplify the denominator, we have 4. So we have 1 plus 2x over x, which is 4x divided by 1 plus 2x. So this is f of g of x. In part B, we want to now to determine the domain of the composition of f and g. You may recall that to be in the domain of the composition of two functions, it has to be in the domain of each of the individual functions. So in order to be in the domain of the composition, it has to be in the domain of f and the domain of g. So let's see what's happening. So we have to evaluate in each case, let's see, g of x, which is defined to be 1 over x, clearly the domain here is what? The set of all real numbers except what? X cannot be 0. So we exclude 0 from the domain of g. All right? So if we exclude it here, it has to be excluded from the domain of the composition of the two functions. All right? Let's move on to f of x. F of x is 4 over x plus 2, but remember, the domain of f of x is going to come from g of x. So g of x plus 2. And as you see here, this is 4 over, so in other words, if I just stop here and look at this, I know from this, whatever g of x is, I know that g of x cannot be a negative 2. G of x cannot be a negative 2. All right? So, let's see where we are here. So g of x can't be a negative 2. So g of x is what? G of x is, g of x is 1 over x. And I know it can't be a negative 2. Because if g of x is a negative 2, what am I doing? I'm dividing by 0, which is not permissible. So I need to find out when 1 over x is equal to negative 2, and for that value of x, I will exclude it from the domain. So let's solve this. So I have 1 is equal to minus 2x, so therefore x is equal to a negative 1 over 2. So when x is a negative 1 over 2, I know that I'm dividing by 0, so therefore, in this case, x cannot be a negative 2. All right, because when x is a negative 2, look, I'm dividing by 0. So what we have here then is that the domain of, let's just put it up here. All right, so the domain of f of g of x, all right, is going to be all real numbers except 0 and a negative 2. Let's express that in interval notation. All right? So the domain is going to be all real numbers less than a negative 1/2 union all real numbers greater than a negative 1/2 and less than 0 union all real numbers greater than 0. So we've expressed the domain of this composition using interval notation.